Hello everyone and welcome to another Java Basics video on the ToborTech YouTube channel. Today's video is about instance attributes and methods in Java programming. So without further ado, let's get started. Today we will continue learning about object-oriented programming by focusing on class methods and attributes. Before we get to those things, let's quickly review what we learned about the last lesson of this course, which is about classes and objects. It's very helpful to think about classes as blueprints for something. In this case, we can think about classes as blueprints for some robots. And the objects themselves are the robots that we create from the blueprints, from the class definitions. But what's in a class definition? What is in the blueprint of our robots? Well, we can specify the properties and the behaviors of our robot. Let's first talk about class attributes. So the properties of an object are defined by the class attributes for that object. So we can write in our blueprint some attributes, and these will define the properties of our objects created from that class. And these attributes are usually information about the objects we create from the class. Using our analogy about robots, it can be the names, the IDs, and the ages of our robots, or it can be something from the manufacturer or the model of our robot. Attributes are really just variables in a class, and we can use these to store information about class instances. So here is a code implementation of class attributes in Java. So we have a pretty simple class, it's only 3 lines. We have a class called robot. So class, robot, and then in curly brackets, we have one variable. And this is how we usually define variables, right? We write the data type of our variable, so which is int, and then we have the variable name age equal to 0, semicolon. So this is how we've always been making variables in Java, nothing new. What is new here is we're defining this straight in a class. Now, usually we define a variable inside of a method. So for example, here we're making a variable called robot1, and this is inside of our main method. This is inside directly of our robot class. That makes age a class attribute of our robot class instead of being a local variable inside of a method. So what that means is we can create a few instances of the robot class. So we're making an object. Robot1 is an object. We're making a new robot, parentheses. This is something we talked about in the last video, so if you need a quick review about that, make sure to check that video out. So robot1 is equal to a new robot, and the same thing with robot2. So we have 2 robot instances, 2 robot objects created. And we can access the attribute age of those objects by writing robot2 dot age. This is accessing the age attribute of our robot2. We can access robot1's age by writing robot1 dot age. And here we're just writing robot2 dot age plus plus. So we're increasing our age variable of robot2 by 1. So we're actually just changing the attribute of robot2, and it's not affecting robot1. So let's take a look at how this is going to work out when I run this code. So let me just put this code inside of our online Java editor from Replit. And we get 0 and 1. 0 is robot1.age. And we didn't change it because, we didn't change this. And because in the class definition initially, the age is set to 0, robot1's age is still 0 because we never changed it. On the other hand, robot2.age got incremented by 1. So robot2.age will give us the value of 1. So that's how we can access values in a class, or I guess it's how we can access the attributes of objects created from a class. So why don't well, we can practice later. We have an exercise coming up really soon. So yeah, let's talk about dot notation. Now we've always been accessing things from a class or from an object using dot notation, even if you haven't realized it. So when we use, for example, methods of hash maps or methods of array lists, or for example, even array.length, if we make an array and we write array, the variable array, dot length, that's accessing the attribute length of our object, which is the array. So that's how we can access object members. And the same idea also applies to class methods. So methods of a class defines the behaviors of the class's objects. So this can be any action. For example, for a robot, maybe it can be move forward, or maybe it can be turn around, or maybe it can pick up some random object. So these are actions that our class's objects will hopefully be able to do. You've actually already been using object methods in many of your programs, like the methods of array lists, hash maps, scanners, and etc. These methods all perform some sort of operation, and they're all part of the class's functionality. So below, we have added one method to the robot class, and it is called in the main class. So we have the robot class, same thing with the age information, and then we have added one method. So we've written public void say hi parentheses, and then in curly brackets we have a print statement. Now notice how we no longer write static here when we're writing instance methods. I'll talk about that in just a second. But right now just write public void say hi parentheses and curly brackets system.out.println and some random message. So in the main class, in the main method, we're making an instance of the robot class called robot. It's equal to a new robot. And we're writing robot.sayHi parentheses semicolon. And that's how we can call a method of an object. So we're calling the sayHi method of robot. So when we write this, Java will look at robot. What is robot? Well, robot is it's an instance of the robot class. So when we call the sayHi method, Java is going to come up here and run the code inside of our sayHi method. Which means if I copy this code and run this program, we'll see greetings human printed out on the right side of our window. Notice that, like I said a few moments ago, the sayHi method has only one modifier, public. We just wrote public here, instead of writing static, which is how we usually write methods before now. So this is something we'll discuss in a later lesson of this chapter. We'll talk about why static no longer appears in the headings of what are known as instance methods. We've been calling this class methods, sometimes calling it even object methods, but they're really called instance methods because they're methods that we call on class instances. This is a class instance, and we're calling a method on this instance of the robot class. Now, besides the lack of static in our methods definition and the way how that we call them, right? We write the object and then dot the method name parentheses instead of just this part. Besides these two differences, instance methods are essentially the same thing as the methods we've written previously. They can do things like take parameters, these are taking inputs, and we can also return values from the method into the method call. Now let's continue expanding our robot class by adding more class attributes and instance methods. So in this exercise, feel free to add more properties and behaviors to our robot class so that any of our robot instances can do more things and have more properties. Now, this is not really a fixed solution, definitely. It's just one of the so many different ways how you can expand this class. So what we have here, let's take a look at what we have here. So class robot, and then we have the age thing that we had before. I've also added a double variable, a double instance attribute called battery percentage. It's initially set to be equal to 100. And then we have a Boolean instance attribute called power on, which is set to false. And then we have the sayHi method we had before. In addition, we have three new methods. We have public void power on. This is going to set the variable power on to true. So we're setting this variable to true now, and we're printing out the statement powered on. And then we have the public void power off, which is the exact opposite of our power on method. So it just sets power on to false and prints out powered off. And then we have a display status method, which prints out battery level, which is equal to whatever the battery percentage is, and then a percent sign. And then if power is on, we print out power on, otherwise we print out powered off. So let us copy this code into our Java editor. And let me just add a main class down here. So class main. And here we need a main method. So public static void main. Then here we take a string array called args. And then in curly brackets. So we can make a robot instance. So robot, let's call this R, which is equal to new robot like this. So what we can do, let's take a look at what we have here. So we have age, battery percentage, power on. Why don't we call say hi first? So let's just write r.sayHi. This is how we can call the instance method say hi. And we can also power on and power off our robot. So let's just, why don't we just do, let's say r.display status first. So we print out the information of our robot, and then we power it on. So power on, and then we display the status again. And let's just leave this robot powered on. Let's take a look at what will happen if I run this program. So we have greetings human, that's from our say hi method call. And then we have battery level 100%. The battery percentage was never changed, so it's always going to be 100%. And r.display status will not only print out the battery level, but also the fact that it is powered off. And then we call the power on method, which is going to run the code up here, including changing the variable and printing out powered on right here. And after we call power on, we call display status again, which is going to print out battery level 100%, and power is now on instead of off because we called the power on method, and the power on variable is now set to true. So let's just actually, why don't we just call r.power off and r.display status like this. And you know what? I've changed my mind. I'm going to add another statement here. I'm going to write system.out.println. I'm going to just put a blank line here so we can actually see what's going on. So we have the say hi, and then the first display status, power is off. And then we call power on, and then we display status again, so 100% power is on. And then we call power off, so power is now off, battery level, power is now off. So this is a pretty interesting program we've written here. It's 41 lines long, and it has a class as some sort of blueprint for robots. And we've made a robot and called a few of the methods that we have defined in the class. There's a lot you can do with classes, a lot of real world objects you can model. Look around you, chances are anything you can see, you can model it with a class and define behaviors with it. In fact, a lot of the actual hardware that you can look at around you, some of the programmings that go into these hardware are likely done with object-oriented programming. Class attributes store properties. This is supposed to say properties. Instance methods define behaviors, and these are incredibly important parts of any class that you will ever write. It's definitely not a bad idea to practice writing a few more classes to get a better understanding of how to use class attributes and instance methods. But we'll definitely be practicing more as we go on in this chapter. And that's it for this tutorial on instance attributes and methods in Java. We hope you found this video helpful. Thank you for watching, and we'll see you in future videos.